All right, so today we're talking about Newton's second law of motion. Second law of motion, work a few examples of this out. You will have a zoom, you'll have a, where is that screen? Oh, it's different order now than it used to be. It's now 1, 2, 3. It used to be 1, 2, 3. So here is my first question. A golf ball hit with a force of 15 Newton travels with an acceleration of 25 meters per second squared. What is the mass of the golf ball? And before you ask the question, do significant figures matter? Yes, significant figures matter. Yes, ma'am. Yes, ma'am. Now, I didn't take off on that vectors thing because some of them are kind of the exact same. Significant figures worked out was the same answers to begin with. I didn't want to confuse you with it. But yes, ma'am, always significant figures. Alrighty, so we got our second law triangle. I could draw a handy dandy little triangle here. So for the second law, F on the top. So Drew's grade goes on the top. M, and the grade Drew's never going to have also goes to the bottom. F equals MA. So if I want to find this out, what am I looking for? F, M, or A? M, so I cover up the M. So M, ooh, that's a wonderful M, equals F over A. What's the force in here, Marnika? What's the force? What's F? Don't say Drew's grade. What's the amount of force? No. What's my value of F? You're ahead of me. 15 newtons. Okay. And what's my acceleration? 25. Put that in my handy dandy calculator, and I get what? Wrong. 0.60. Because I need two significant figures. And my units of that, what's my units of mass? Nope. Kilograms. Alrighty, so there's one example. What? No, not at all.
Wouldn't the force have been kilograms / meters per second too, and that equals newtons as well?
Yeah. All right, let's see here. Let me try to find a little bit of harder one.
I ain't gonna write down the probably most part. I wrote so slow. Whenever I would do your notes, I would just pause the video. I would stop you talking and just write everything down. And instead of spending like 10-15 minutes on the video, I'd spend like 30-40 minutes.
I wish I could see how long you spend on those things, but I cannot.
30-40 minutes. What? Every time he talks, I slowed down and sped up how you talk.
Okay, so this one we're talking about a sedated lion. The total mass of the lion, the stretcher is 175 kilograms. The upward acceleration on the lion and the stretcher is 0.657 meters per second squared. What is the force required to produce this acceleration of the lion and the stretcher? So that is our wonderful question. And so this one, I'm not going to draw my handy dandy triangle, but I'm looking for force. And so F equals MA. So I'm going to multiply these two things. So F equals MA. And my mass is 175. My acceleration is 0.657. That's some wonderful handwriting. And what's my answer? What? I need three significant figures. 115, and that would be newtons. F is multiplied. 15. There's that. How's this different? I mean, how's it different?
Like, I thought you said it's gonna be a little different.
It could be a little different.
It's probably gonna get harder and I'm gonna regret that.
No, let's get harder right now. Let's get harder right now.
Can I use your extra?
Yes, ma'am. It's right there. What is the magnitude of the force that exerted on a 20-kilogram ball that is falling? So this is still force, mass acceleration, so I'm still going to use F equals ma. Sort of. So let me pick on Claire. What is the mass in this problem? Give you a hint. You got the easy one to figure it out. What's the mass? It's the mass of the ball. 20 kilograms. Soma, what is the acceleration? Oh, there are no more numbers. Oh, but there is one that is implicitly implied. No.
9.8 meters per second.
Incorrect, but correct. Acceleration due to gravity on Earth is 9.81 meters per second squared. Yeah, it's in our video. This is why this is called, the only thing that's really different about this is called the weight triangle, okay? Acceleration due to gravity is always 9.81 meters per second squared on Earth. It is different than other things. This is why this second law is also known as the law of gravity, okay? So plug these in. And you get what? What? Is that correct? 196.2. I need uno significant figure, so it would be 200. All righty. We'll do what? Where's my mouse? It's very confusing. 200 newtons. Forces newtons. All righty. Let's do one more example. Last example. Oh, it's really confusing. I don't know why my thing, but I actually kind of like it a little bit better this way. I have a mass of 212 pounds. What is my weight? Oh, look at my new computer screen I borrowed. Ooh, it raised it. It was $3.98. It cost $3.99. We have a surplus room, and I just went and borrowed it out of it. But ooh, it's so cool and so fancy. Got it. I have a mass of 212 pounds. What is my weight? That's a true statement. I have a mass of 212 pounds. All right, so let's work this one out. I'm going to use F equals ma, correct? Or I can use W equals mg, either same thing. Because weight is a force. Weight is a force. W equals mg is the same thing as F equals ma, okay? They use W equals mg for, you're talking about gravity, things accelerating on Earth. I could have done the last one. They, for some reason, scientists decided they were going to use G for acceleration due to gravity. Don't really know why, but in fact they did. So F equals ma or W equals mg. Same thing, okay? So weight is a force, so its answer will still be in newtons. G is acceleration due to gravity, so it's still an A. So either way you want to do it. I'm going to use the W one because I just prefer the W one. So W equals, well, that's horrible handwriting. What's my mass? Wrong. What does the mass have to be in what unit? It has to be in kilograms. So I have to convert from pounds to kilograms. I have to convert pounds to kilograms. So over here, I'm going to have 212 pounds. Take what I know. Over 1 times in 1 kilogram. This is a conversion factor that we went over. So it's in your stream, or you can just Google it, 2.2 pounds. So someone needs to do 212 divided by 2.2. That will get my number of kilograms. My mass should be in kilograms. And I started with 3 significant figures, so I'm going to end with 3 significant figures. Okay. 96.4. So my mass is now 96.4. And what's the value of G? 9.81. 9.81. Put that in your handy dandy calculator and you'll see how much I weigh. Yes, ma'am. Yes, I made it. Yes, ma'am. It's 1 against a significant figure. I don't know the exact number, but that would give us 1 more significant figure. Yes, ma'am. Good job, Marnika. What? Yeah. 945 newtons. 946. Dang it, Drew. You're an embarrassment. I have to get out my little teeny tiny eraser. Look at this. How big that eraser is. I don't know how to do that. I do. But it doesn't increase it that much. So boo. 946 newtons. So I have a weight of 946 newtons. So you can figure this out for yourself and be like, Mom, you know I weigh. Mom, guess my weight. Or you go like Six Flags and they say, it's the guess your weight. And they're going to tell you the answer in pounds. It's going to be wrong. And then you can be like, give me my $5. They still do that at Six Flags. I've only been to Six Flags like 2 or 3 times. And that was just one of the things I did. They guess your age. Like this spot, they can guess your age. This spot, they guess your other thing. All right, so you got any questions about Newton's second law of motion? All righty then. You'll have a quizzes. And if you have any questions, please let me know. Yep, you have a new one.